Okay, today I'm gonna summarize the thin film deposition of the fabrication technology. Deposition is being some thin film deposit on the surface in in semiconductor. So there's two types of the deposition, and first is the chemical vapor deposition. It causes CVD, and secondly, and physical vapor deposition, PVD. And CVD is works in chemically into the surface. So and PVD is physically react in the surface. So deposit thing is not the film into the layer. It we help the surface on the growing their films. So there is a three model of the growth mode. First is the layer to layer growth. It is the very long. It needs a long time and high temperature, but it makes a really stable, and it has the same height and everywhere and at the same times. And secondly is a 3D Iceland growth. It's born when we deposit the film in the pipe of the vapor. Their film atom is bonding to the not to the surface. It bonding to the strongly itself and each other. So it make a 3D model position. So we call this thing is a Iceland growth. And second is a mixed growth. And this is the mix of the Iceland growth and layer growth. Below of the deposit film is a layer growth, and when the condition is completed, there is atom is bonding each other strongly, so it makes a Iceland growth. So we can see this growth time, the first time in the layer growth, and some condition is completed, and there's other things is make a Iceland growth. It and this makes a 3D things in the surface. And there's a state of the film. The film crystallinity first is a epitaxial. We call the epitaxial. It means a single crystalline, and in single it means a single atom. So this is really pure and stable, and also it need high temperature and long times to grow. So this way is make a high quality. And polycrystalline. And polycrystalline is made by the Iceland growth way and mixed growth way. Polycrystalline is usually it use a very variable thing, and its structure is several many of the crystalline structure. And so this is amorphous state. It also made by the Iceland and mixed growth way. And then there's a step coverage. In this deposition process, step coverage is very important because we use these ways in every process. And there is the two types of the coverage. And first is conformer type coverage and non-conformer types. You can see this figure. conformer is to have a same thing in everywhere, and this is need to long time, and because of the it makes this film in the step by step. But non-conformal film is make a not a not there's not the same thing in everywhere because they deposit in short time and not the step by step. But it is tricky to determine how is good and this way is bad because depends on its application. Non For example, non-conformal ways of the step coverage, it makes there's some plate and we deposit the non-conformal things and we can see the metal and we deposit the something we needed into the surface and we can use it because of this non-conformal thing makes a more smaller and other application. But in the fin structure and GA structure, it need a formal film depression. It need a formal depression. And other, we can use this step coverage is poor because isolation of the line, how we isolation this line is that we make a void of the between the line to line. Because it's air, it's very low K materials, it makes isolation is so good. So this step is need the poor step coverage. This time I'm gonna end of the this normalization. Next time I will do the last thing. And okay, thank you.